All right, well, Chapter 4, Lesson 6. So moving right along. This is called fitting a line or fit a line to data. So we're going to talk about some data. And first thing we're going to do is talk about a scatter plot. And most of you guys have probably heard of a scatter plot. A scatter plot is a graph used to determine whether there is a relationship between paired data. This is used in the business world a lot. It's used in science. It is used in experiments, just trying to see if there is any kind of relationship existing between two different items that you're comparing. So scatter plots can show trends in the data or the data. Here are some examples using scatter plots to find trends. Okay, if you notice, as this is called a positive correlation. As x increases, because this right here is your x, and this would be your y. So as x increases, y also increases. So it's a positive correlation or going uphill. This will be a negative correlation because as x increases, y decreases. As this increases, this decreases, or this decreases. And this is no correlation. Obviously, it's just random. There is no relationship between x and y, whatever those categories may be. And this happens in experiments. It happens in business, and just seeing if x and y are related, and in this they are not. They are not related, so there's no correlation. So there we go. If y tends to increase, as x increases, it's positive. If y tends to decrease, as x increases, it's negative, and obviously they have no apparent relationship. All right, so example 1 is talking about just describing the correlation of the data. So obviously we can look at this and notice our x is our hours of studying, and this is our test scores. So we notice that there is a positive correlation between hours of studying and test scores. The more homework or studying you do for a test, it should make sense that the test scores would also increase. So as hours of studying increase, the test scores increase. Positive correlation. Example B, or part B for example 1. Notice this one is hours of television watched and test scores. So as the hours of television watched increased, our test scores tended to decrease. Now that may or may not be true, but you never know. Obviously, if you're watching more television, you're spending less time studying possibly. So that could be the reason there's a possible negative correlation. Less TV viewing, more studying, scores were higher. So negative correlation, because as x increases, y decreases. All right, example 2, we're going to make a scatter plot and then see if there's any trends or see if we can describe it. So the table shows the lengths in centimeters lengths in centimeters and swimming speeds in centimeters of 6 different types of fish. Actually, it shows 5. So that should say 5 different types of fish. 1, 2, 3, 4, 5. Okay, so we have these, the length of the pike, and then it's probably average swimming speed. The length of this, average swimming speed. So the first thing we're going to do is make a scatter plot of the data. Okay, and then we're going to describe if there is a correlation. There may not be a correlation, maybe no correlation. So we're going to treat the data as ordered pairs, and so let x represent the fish length in centimeters and y represent the speed in centimeters per second. Now, the reason we're treating length as x and speed as y would be because we're trying to see if length has anything to do with speed. Okay, length would be our independent variable, and speed would be our dependent. Is speed related to length? That's kind of our question. Obviously, the faster a fish is would not have anything to do with, like, okay, the faster it is, that means it's going to grow longer. So our length might determine speed, whereas speed is not going to determine how long a fish grows or how short a fish grows. So always remember, this is independent variable while this is dependent variable. Okay, so we've plotted these points. These are all the points from this right here. Okay, we just used the length 37.8 and then went to speed, and I'll show you that. So the pike was at 37.8, which was about here, and the speed was almost 150. So see, we've graphed each of those fish by their length and speed. And the scatter plot shows that there is possibly a positive correlation, and it might mean that longer fish tend to swim faster. Now, I would say with 5 pieces of data, we might need more data, But with even those 5 pieces, you can kind of see a positive upward trend. Okay? So you can kind of see that. But I would need more data. All right, example 3. This is going to be the tough one. Write an equation to model data. Okay? Writing an equation to model a scatter plot. Okay, that's going to be interesting. So just bear with me. It's fairly, it sounds complicated, but we'll practice. The table here shows the number of active red something, I don't know, woodpecker clusters in a part of the DeSoto National Forest in Mississippi. Write an equation that models the number of active clusters as a function of the number of years. Okay, time is always your x, and then our active clusters will be our y, but time is almost generally always x because time is independent. And so we're looking at this. So we can kind of see a trend here already. From 92, there were 22 active clusters, and it gradually seems to kind of increase up to the year 2000 where there's 51. So we can already see that as x increases, y increases. So we can see there's a positive correlation. Okay, so but the first step is to obviously plot your data. Okay, make a scatter plot. So here's all of our scatter plot, and treat each one like an ordered pair. So let x represent the number of years since 1990. So we start with 1992 because that would be, 2 years past 1990 would be 2. This would represent 1992. This would represent 1994. This would represent 2000. Okay? Just to show you, but years since 1990, that's how we get to just the single digit numbers. Okay? And let y represent the number of active clusters. So we plot our 2 and our 24, whatever, or 22, and then in year 3, year 4, year 5, year 6, 7, 8, and so on. Okay, and we can obviously see there's a positive correlation. Okay, so step 2, obviously it says, decide whether the data can be modeled by a line. Because the scatter plot does show a positive correlation, you can fit a line to the data, which on your notes you have that line right there. Sorry, I'm kind of slow. You have that line. So you can fit a line to the data. So that means we can kind of estimate a line of best fit that models the trend we're seeing. So your step 3 would be to draw a line that appears to fit the points in the scatter plot closely. You need probably about half the points above your line and half the points below your line. They don't have to be on your line at all. None of the points might sit on your line. Maybe part of the points sit on your line. It doesn't matter as long as it kind of models a good trend. So make sure that if none of your points sit on your line, about half are above and half are below. So you would draw a line to do that. And then for writing an equation, you use 2 points on the line you drew. So on our example, we're going to use 220 and 842. So look at those, and it's about 842. We're kind of guessing on the y coordinate because we don't have an exact y coordinate. We have an exact x, but we're kind of going ahead and guessing on the y coordinate, and that's okay. Now, are these even values on our chart? Were these even part of our table? I don't think they were. They're points that we chose from the line we drew that models our data. They don't have to be values on our chart. They can be, but they don't have to be. So we're going to choose those 2 points, and what do you think we're going to do with those 2 points? Okay? That's why it's not an estimate on this. This one is a given value. So we have one that we chose on our line and one that's given. That's pretty close to our line, if not on our line. Okay? So the next thing we do with those points is we find the slope of those points that we picked from our line. And our slope is 11/3. And you guys, when you pick points, random points, you're going to get messy slopes. You're going to get fractions for slopes. It's okay. You can handle it. So there's our slope. We're going to find the y-intercept. We're going to use this point, and we're going to solve for b. So here's our slope-intercept form. We're going to substitute our points in. We're going to substitute 20 for y, 11/3 for slope, and 2 for x, because this is the point we're using. And we're going to solve for b. Solving for b, we get 38 thirds. So now an equation for our line is 11 thirds is our slope, x, plus 38 over 3 for our y-intercept. Now, if we wanted to estimate how many clusters there would be in the year 2020, then we could say x is our years since 1990, correct? So we could say our years since 1990. So if we were trying to look at 2020, that would be 30 years since 1990. We could do an estimation of and find out how many clusters there might be, or approximately how many there might be in the year 2020 by using this equation. That's the point of a line of best fit. It is for predicting data, and we'll talk about that tomorrow. So there's your equation. You can stop the video and do your guided practice.